Thank you for joining this lesson. We're going to discuss errors and approximations. We are told to calculate the percentage error in the volume of a cone of radius 7.0 centimeters and height 20 centimeters. Remember to subscribe to this channel and to also share the link with friends. So apart from the general knowledge on errors, it's good for a student to be alert on some concepts like the volume of a cone. A student who doesn't know that formula will be doomed, no matter how conversant she is or he is with errors and approximations. Now, to begin with, we don't just begin with percentage errors. We begin with the range of the recording of these two dimensions, which is the radius and the height. So for the radius, which is beginning from 7.0, this one has been recorded to the accuracy of 1 decimal place, and therefore we say the percentage error of recording this radius is when we take the accuracy of 0.1 and we divide it by 2, which is 0.05. Therefore, we add and subtract 0.05 to this, and we find ourselves having a range of from 6.95 centimeters all the way to 7.05 centimeters. So that is the range of recording the radius. The other dimension is 20, which is the height. So plus or minus. 20 has been recorded to the nearest whole number. Therefore, the absolute error will be, because it is the nearest whole number, 1 out of 2, which is 0.5. Therefore, we add and subtract 0.5. Then we'll get a range for the height of 19.5 all the way to 20.5 centimeters. After getting the range of the recording of all these values, the next thing to do is to calculate what we call maximum volume, minimum volume, and the working volume. So volume maximum is going to be, remember we give volume generally, let me write the general formula here, a third of base area, and because it is a cone, the base is circular, so pi r squared, this is now the base area, times height, a third pi r squared h. Therefore, for the maximum volume, we will need a third times pi, can have 22 out of 7, multiplied by the area. Because we want the volume maximum, then we have to take the maximum value of r, which is going to be 7.05. Now this is what we will square, multiplied by the greatest height, which is 20.5. So I can now compute this using my calculator. When I take 22 multiplied by 7.05 and I square this, then I multiply by 20.5. Then now everything is divided by 3 times 7. This is going to give us 1067.42. 1067.42 cubic centimeters. The next is volume minimum, which is going to be given by a third pi. Then radius, we use the least radius, 6.95. This is what we will square, multiplied by h, which is a 19.5. So when we compute this, I'm taking 22 times 6.95 squared multiplied by 19.5. Then I divide everything by 3 times 7. This is going to give us a 986.75. This is a cubic centimeters. That is all about the minimum volume. Then we can go to volume, the working volume. We can even call it an actual volume. So for the actual volume, we use a third pi. Then the radius, we use it as 7.0 squared, the way it has been recorded, multiplied by height of 20. So we use, for actual values, we use how the dimensions have been recorded. Therefore, I'm going to have 22 by 7 squared multiplied by 20, then I divide by 7 multiplied by 3. This is going to be 1026.67. 1026.67. This is a cubic centimeters. So now we have volume maximum, volume minimum, and the actual volume. For us to get something called a absolute error, for us to get absolute error in the calculation of volume, remember there was absolute error in the recording of values, which was for radius 0.05 and for the height 0.5. That is about the recording. Now in the calculation, there is what we call absolute error in this volume, whereby we will take volume maximum 1067.42 minus volume minimum 986.75 divided by 2. So this is going to be, when I take 1067.42 and I subtract 986.75, this is going to be, when I divide by 2, sorry, this is going to be 40.335. That is the absolute error. The other thing to calculate is what we call the relative error. The relative error. And here we will say that a relative error is given by absolute error divided by actual volume. So when we take the absolute error and we divide by actual volume, 1026.67, we're going to get 0.03928 or 929, which means now the percentage error which is usually given by relative error times 100 will be 0.03929 times 100, and this is going to be 3.929%.